guys, we're going to talk about if-then statements in geometry. Let's go ahead and get started. Geometry is half measurement, half logic. This week we'll be learning about some of the logic behind geometry that results from if-then statements. But why is logic important? Let's think about this for a second. Penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. I don't think so. So this is why we need logic, because we don't want to be like penguins who aren't very good at it. An if-then statement is just that, a statement that contains an if portion called the hypothesis and a then portion called the conclusion. For example, in the if-then statement here, if you do not take showers, then people will not want to sit next to you. The red portion is the hypothesis and the blue portion is the conclusion. Notice that the if and the then actual words themselves are not red and they're not blue. They're just part of the statement. So what comes after the if is basically the hypothesis, and what comes after the then is basically the conclusion. Now this week, we'll be focusing on 4 kinds of if-then statements. We have the original statement, which I just gave you. We have the converse, the inverse, and the contrapositive. So let's get started. Let's say we have an original statement that is, if an animal is a penguin, then it is a bird. Let's go ahead and just keep that right up there for reference through this whole lesson. Okay, so the converse of a statement reverses or flips the hypothesis and conclusion. So the original statement was, if an animal is a penguin, then it is a bird. The converse reads, if an animal is a bird, then it's a penguin. Alright, I'm sure some of you noticed I didn't actually take the whole hypothesis and the whole conclusion and switch them, but that's okay. Really, as long as you know that you're switching the first part and the second part, you have a converse right there and everything's fine. But if I ever ask you on a test, if you're ever taking a test, and it says, what's the hypothesis? Then you should know that it's the statement, an animal is a penguin. Okay, let's move on. The inverse of a statement negates or puts nots into the original statement. So notice that the inverse, see those first 2 letters, I-N, it puts nots into a statement. So for example, the original statement, if an animal is a penguin, then it is a bird. The inverse would read, if an animal is not a penguin, then it is not a bird. Okay, but a contrapositive does both. It's the converse and the inverse. So basically, whatever you can do, you do it. So the original statement reads, if an animal is a penguin, then it is a bird. Well, then the contrapositive reads, if an animal is not a bird, then it is not a penguin. You can actually say that the contrapositive is the inverse of the converse, or even the converse of the inverse. The last thing to remember is that just like when we discuss patterns, not all statements are always true. That's where counterexamples come in. Let's look at our examples again and provide counterexamples for the false statements. So if it's true, we'll just say it's true. But if it's false, we have to say it's false and provide a counterexample. Okay, so our original statement read, if an animal is a penguin, then it is a bird. So let's see, is this true or false? Is it always true? Let's think about that for a second. Yeah, it's always true. If an animal is a penguin, it has to be a bird. A penguin is a type of bird. Okay, let's go on. Our converse read, if an animal is a bird, then it is a penguin. So let's see, is this always true? I don't think so. Here's the problem. Just because something is a bird doesn't mean it has to be a penguin. So our counterexample could be, a crow is a bird, but it's not a penguin. Another counterexample could be, a turkey is a bird, but it's not a penguin. Okay, so our inverse read, if an animal is not a penguin, then it is not a bird. That's not true either. Our counterexample would be, a dove is not a penguin, but it's definitely a bird. Just like a pigeon is not a penguin, but it's a bird. And finally, our contrapositive. If an animal is not a bird, then it is not a penguin. Now this is the trickiest one, so let's think about it again. Is this true? Always true? If an animal's not a bird, then it's not a penguin. Yeah, that's actually true. These can be kind of tricky. If something isn't a bird, then how could it possibly be a penguin, right? That's why it's true. Alright, now you try. Give the converse, the inverse, and the contrapositive of the following original statement. So get out your pencil, get out your paper, and let's go ahead and write this down. Our statement is, if x squared equals 25, then x equals 5. Go ahead and press the pause button and give the converse, inverse, and contrapositive. Alright, let's see how we did. Our original statement stays the same. Our converse gets flipped. Our inverse is just like the original, except now it says is not equal to. And our contrapositive looks, well, just like our inverse, but flipped. Okay, so now you're going to say true or false for each statement. And if it's false, you have to provide a counterexample. So go ahead and press pause again, and then play when you are ready. Did I trick you? Because the first one was false. So false. But totally tricky. If x squared equals 25, then x equals 5 is sometimes true, absolutely. But x could also be negative 5, right? Because negative 5 squared equals positive 25. So the first one was false. The converse, definitely true. Hopefully you didn't have a problem with that one. If x equals 5, x squared equals 25. The inverse, also true. If x squared doesn't equal 25, then there's no way x could equal 5. That just doesn't make sense. Okay, the contrapositive, it says, if x doesn't equal 5, then x squared doesn't equal 25. Well, that's not always the case. Even if x doesn't equal 5, we can still have x squared equals 25 because x could be, again, negative 5. That was quite tricky, huh? But I wanted to give you something that was pretty much as hard as it can get. So good luck. Do your homework that was assigned. Ask me lots of questions if you have them. And try not to be a penguin, even though they're super cute and always dressed in a tuxedo.